Hey everybody, this is Larry. This is day 16 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Apparently I've done this recently. I don't know if my Firefox or whatever is just having a good memory. But yeah, today's problem is implement queues using stacks 232. Easy problem. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. So this is actually I probably talked about this before, and I've done this problem a few times. Oh, only once I lied. Actually, only a few days. So maybe I haven't talked about this before. I mean, I know how to do this, so that's why. Sorry if it's a little bit spoiler alert. But a little bit of a minor story time is that I never forget this problem, even though now is easy apparently. But it was an interview question for me really early in my career. And this is what year is this? 2022, almost literally 20 years ago. So and I honestly did mess this up because back then there's no studying, and even though this problem at the time was legitimately new to me, right? So and even though I did do some competitive programming type things, even though they weren't called that back then, I think it was just something that the standards were a little bit different back then in terms of a little bit less algo, at least in my region, a little bit less algo, a little bit less data structure, and a little bit more just like hardcore implementation-y type things in my region anyway for competitive. So that's why I don't know. I mean, I did obviously figure out this one and have a very strong memory, say, of this one because of that reason, because this was a very sad thing to me because I did get this one wrong, and I think I didn't I just didn't get this one in a really good time, even though now is easy apparently, and this is a long time ago, and that journey is a long time. So you do get better, you do make mistakes, and you do learn from your mistakes, and it's something that I'm just kind of every time I see this problem or whatever, I'm always like I mean, I would say though, even at that time, I knew that I just didn't know how to do it. I think at the time I was struggling because I was still new with this idea of amortized analysis, and we'll get into that part a little bit. But basically, it's just the idea of amortized analysis, and I wasn't quite. I mean, I had some framework mentally, but I wasn't as practiced and rehearsed as I am now with respect to amortized analysis. And the other part of that, though, even then, I knew that because the question was more open-ended when I got asked in an interview, which was like, it was basically like, if you're given if you're given only stacks, can you implement a queue, right? So it wasn't like a foregone, at least at that time, conclusion that you are able to do it. I mean, of course, if you knew the literature, but it wasn't like, we know that you can, or like that's not how the question was asked to me anyway. And that said, I was trying to be like smart. I was like, I took my theory of computation class, and and if you remember that class, if you're in that class, or if you took that class about like, it's just a class about complexity theory and analysis of complexity and stuff like that. But one of the things that it talked about was this idea of a Turing machine, or not Turing machine, is it? No, yeah, huh. Yeah, Turing machine, right? So I sometimes I get confused, or I mix up Turing machines and Van Neumann machines, and of course, as I'm doing these live, so if I'm a little bit inaccurate here, if there's a bit of inaccuracy, my apologies. But these are just like story time more than anything. And of course, you can skip forward, but maybe I should have said to skip forward a little bit earlier. But yeah, if you remember from your theory of complexity, if you remember your Turing machine, then you know that having two stacks is Turing complete. One stack it's not, two stack it is, right? Because now what do you call it? Because now having two tapes, you can you know, it's already a Turing machine, and that was the other thing that I was trying to think about. Oh yeah, because and you know, and you get into this idea about tapes and languages and stuff like that, because with one stack, it turns out that you can only recognize regular. Is it no, what's the stack? Ah man, I forget the name of these things, but you can only do okay, never mind. Maybe I can't remember the name of all the vocabulary. It's been a long time, so apologies for that. But yeah, but basically, you know, so I knew that using two stacks would be sufficient, but it took me, and I was, and we have two stacks. It's kind of obvious how you implement it, and I did get. I think maybe I lied a little bit by saying that I got the wrong result, but no, I mean I got the answer at the end, but it wasn't very smooth because I was trying to figure out like, is it okay? Like I said, I struggle with a lot of amortized analysis, and judging by my Discord, and just conversations, is something that is not unique to me. And even, you know, this is of course when I was more of a beginner, but you know, so but even then I was, you know, a little bit more advanced on the beginner. So it is very easy to get make a mistake on the amortized analysis, or just like really wrapping your head around it. But yeah, so we'll go over it now, and yeah, let's just have two stacks. Let's just say have a left stack and a right stack, right? And the way that I think about these is that you can, and I didn't have this visualization when I was coming with from scratch, is that you can think about it as, I'm trying to think of this a way I can draw this, but basically you can think about this once, you know, instead of two stacks like this, left and right, you could kind of turn them away from each other, maybe something like this, so that your left stack, you know, and then if you visualize it that way, then it becomes a queue, right? Maybe I could draw it here in ASCII art because I'm okay. Fine. Let me just put out the paint real quick. I'm just a little bit lazy today, maybe. But my computer's a little bit messed up, so give me a second. Put it on the screen. Also, I just got my and I got the flu shot, and I got the other the new COVID vaccine. So my left my left shoulder is kind of really sore right now. But anyway, my thing about this visualization, which I think is, I don't know, I like it. I think it's cute. You can, you know, it's just that you can think about the stack as two stacks going from left to right, something like this, so that as you know, as long as you kind of make sure you keep track of some invariants, then it should be okay. For example, if you put like A, B, C, right, and then now you want to put it on the other side, then it would go from, you know, C, B, A, right? And then now, and of course these are no longer here, but you can kind of see it like visually as a queue as you kind of, you know, do it this way. And with and you know, I talk a lot about visualization on this channel because I think that once you have the right visualization and ideas, the implementation is just following through, right? I mean, sometimes you have silly off by ones, as I often do, but the idea is the core part of allowing us to kind of go on. The invariant here, though, of course, is that one of the stacks, you know, we have to be careful about it. Okay, so anyway, so push, we always push to the left, right? Pop. I mean, you can, and as long as you keep track of these invariants, it doesn't mean, like, there may be some variation in how you want to do it, but it'll be okay. But yeah, so if length of self.right is greater than, if it's equal to 0, then while's length of self.left is greater than 0, self.right.append, self.left.pop, right? And then basically now you're popping everything to put in the front, and then now we return self.right.pop, right? Peak, so empty, let's do empty first. Basically return length of self.left plus length of self.right is equal to 0. And peak is, I mean, and I'm a little bit lazy today, but probably we could have done this with a decorator or something like this. I don't want to go over. I know that this is like Python magic and it's something that I definitely recommend. Like once you're more familiar with Python, you'll do it. But here, we'll just do this for now, and then I want to see what if we peek on an empty thing. Okay, so okay. Yeah. And of course you can maybe just do like a quick maybe readjust things as a decorator afterwards. So then you can do self maybe adjust. And yeah, and let's give it a quick submit because I'm too lazy to check. And it looks good. Yeah. So yeah, I mean, let's do this in a naive analyze, right? Analysis. So this is going to be O of 1. This is going to be O of n because, at most there'll be n elements, right? And as a result, this is also O of n, and this is O of n, and this is O of 1. So then the question is, okay, well, in that case, isn't this n squared? And this is where, the amortize, and I think that's one of the thing. Yeah. Well, I mean, I already did this, and this is already that, but basically the idea is that, okay, what's another way of thinking about it, right? Well, we think about it in terms of, we think about it right now in terms of per function, but what we could do, and in this case should do for a more tighter bound, is do this amortization analysis. And in this case, yeah, in this case, instead of thinking about it in functions, you should think about it in terms of elements, right? Well, and what I mean by that means that for every element that you push and you pop and you, I don't know, peek, I guess doesn't really count, but the question is, okay, what happens through the life cycle of every element, right? And what I mean by that is that, okay, so I'm a little element going through this array, or throwing this data structure, this abstract data structure, and first it gets appended to self.left, right? And it only happens once, and this is an O of 1 operation. And then maybe at some point it gets, moved from the left to the right. So that means that also is 2 O of 1 operations. The pop is O of 1, append is O of 1. And then at the very end, it gets popped from the right, maybe it gets peeked at some point, but it can only, so if you think about the state machine, if you will, maybe that's another better way of thinking about it, or just different way of thinking about it. If you think about the state machine of where it is, where the element is at every given time, well, it can only go through one of those stages every time once. So it's going to be O of 1. And in total, because there are n element and each element will only do O of 1 operation on the system altogether, this is O of n amortized in total, or O of 1 per operation. That's pretty much all I have for today. I am very hungry. Don't know why. So I am going to go eat. No bonus question today. Yeah, that's all I have though. So stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.